Hey guys, Mr. Bowman here. Today's learning objective is in green, and we are learning to identify the features and equations of hyperboles. So we've gone through hyperboles before, but we're going to take a slightly different approach in determining this equations, and we're going to be using a multiplicative approach. So our equation is going to be x plus a, x plus b, and that's equal to c. If you do rearrange this, you'll see the approach we looked at before. So y plus b would have been equal to c divided by x plus a, and then y would have been equal to c divided by x plus a minus b. And that equation looks very similar to what we did earlier on in the year, but we're going to be focusing on that top equation. We're going to start off with our four examples, which are in the bottom left. We're going to call them by their colors, but we're going to start off with the red graph, and we need to identify the A, B, and C to finish off the equation. And I'm just going to show us how to do that. So the first step is to identify the asymptotes of the equation. And I'm just drawing a line. Hopefully you recall what asymptotes are. Apologies about the straight line. So those are our asymptotes for there. And our asymptote intercept is at point 0, 0. So the A relates to how much this point has been moved left or right. So because it's still on 0, 0, that means A will be equal to 0. Similarly, because B is on 0, 0, that means that hasn't moved. That's going to be 0. And C's a bit trickier. C is where we try to find a nice point. So I've identified a point on our red parabola, a red hyperbole, which looks nice, and if we go across, we kind of form what looks like a rectangle. And C actually relates to the area of that rectangle. So it goes across 2 units, and it is a height of 3 units. 2 times 3 is equal to 6, and that means our C value is equal to 6. And when we form our equation, we'll finish it on the right, that means it's going to be x plus 0, y plus 0, and that's going to be equal to 6. And that, when simplified, x times y is equal to 6. So hopefully that is beginning to make sense. We're going to get into some harder questions now as well. So we're now going to look at the purple hyperbole just to see what that comes up with. And same deal, we need to find A, B, and C. And same starting point, we need to find out the asymptotes of this graph. So the asymptotes here, I'm drawing the line. This is the horizontal asymptote. It looks like that is the vertical asymptote, and that new dot is where those asymptotes intercept. So what makes this one a little bit difficult is the asymptote intercept is meant to be at the origin, but we can see it's been moved, and that's what's going to affect the A and the B values, is when that intercepting point moves. So first, let's have a look at the A value. So A relates to how much has it been moved left or right on the x-axis, and it doesn't look like it's been moved left or right, it's only been moved down. So that means our A value is equal to 0. The B, that relates to how much it's been moved up or down, and we can see it's been moved down -2. And it's really important to note that the A and the B value, when they move, I'm writing it down here in big letters, we always deal in the opposites. So because it's been moved down to -2, the B value is going to have the opposite value of +2. We now try to find the C value, and that's where we form a rectangle or a square on our thing. So we can kind of see I've accidentally drawn all over this portion of the graph, but let's look at the other side of it down here, and I can see this point here really well. And from our point, that tiny portion there is our rectangle or our square, and it's 1 by 1. So that means the area of that rectangle would be equal to 1, which means C would be equal to 1. And with that information, we found out A, B, and C. We can figure out the equation of this graph. So technically, it's going to be x plus 0, y plus 2 is equal to 1. We can simplify the first part by doing x times y plus 2 is equal to 1, and that there would be the equation of our purple graph. So we're now going to have a look at our blue graph. First step, as always, is the asymptote. So let's draw our horizontal asymptote, and again, let's draw our vertical asymptote. And let's draw our new interception point, and that point has been moved from 0, 0. So it's gone from here to here, and that's where we figure out the A and the B value from. So we're now going to work on the blue one, and our A value relates to the x-axis, and it relates to how much it's been moved left or right. So we can see it's been moved across to -1. The opposite of -1 is +1, which means our A value will be equal to 1. We can then have a look at B. B relates to the y-axis. So we can see it's been moved up 1, 2, 3, 4 units. The opposite of +4 is -4. So that means our B value would be -4. And the last step, let's try to make a rectangle or a square from a point. And I can see this point here down the bottom quite clearly. And we can draw a rectangle from there. So that rectangle has a height of 1 and a base of 3. 1 times 3, that gets us to 3. And that means we can confirm our C value is equal to 3. So now that we've got A, B, and C, we can put all of them together to finish up our equation. So x plus 1, y minus 4, that there is going to be equal to 3. And this time around, there's no simplifying to be done because we have no zeros in our equation. Well done if you got that. Final equation we're going to do in this one is the green equation. So let's have a look at our green graph. First step is to locate your asymptotes. So I'm drawing in my horizontal asymptote along there. I also need to draw in my vertical asymptote, which looks there. The drawing's not perfect, but that there is our new point. So that means our origin, or our asymptote intercept, has moved from the origin to our new point. And we can use this to figure out our A, B, and C values. So A relates to the shift along the x-axis, so it's been shifted across 1, 2, 3. The opposite of 3 would be -3, so that means A is equal to -3. We can then do the same with B, so B's gone down 1, 2, 3, 4, 5, so that there would be -5. Opposite of -5 is +5, so we can confirm that B is +5. The last step relates to the square or the rectangle. So let's find a nice point on our graph. So down the bottom, just highlighting it in green now, we can see that clearly, and there's our rectangle. It has a base of 2 and a height of 4. 4 times 2 is equal to 8, and that's our C value. So we can say that C is equal to 8 for that graph. And when we plug that into the equation, x minus 3, y plus 5, that there is equal to 8. And that there would be the correct equation for that green graph. So hopefully you found this video useful. Just looking to recap, make sure you find out your asymptotes first. Make sure you look where the asymptotes intercept, and that will give you all of the information you need to find the equation of a hyperbole using this new multiplication type formula. Hopefully you found the video useful. Let's get into heaps of practice.